Hello friends. Now in the previous video we have finished the all five theories of failures. Now by using the principles of these theories of failures we are going to design a component here. So for that I have given some example here, numerical examples of theories of failure from the books. First example is the load on a bolt consists of an axial pull of 10 kilonewton. This 10 kilonewton together with a transverse shear force. Shear force is also given as 5 kilonewton. So diameter of bolt required according to the maximum principal stress theory, maximum shear stress theory, principal strain energy, distortion energy theory, we need to find it out. Okay. And elastic limit is given to us 100 megapascal and Poisson's ratio as 0.3. Now let's see the given terms. We first write the given terms here. Okay, these are the given terms here. PT1 10 kilonewton, 5 kilonewton, and all this thing. We all have the values in Newton. So take value in Newton or convert it in kilonewton. Always remember that the unit should be same. This is the diameter of the bolt. Now just consider the area of a bolt, that is area is equal to pi by 4 d square. Okay, so pi by 4 it is what, 0.7854 times d square. So we get the area here first, and the axial tensile stress is what, sigma 1 is equal to pt1 by a. Now this is what, upon area it is already given, and the tangential load. Okay, the axial pull is given as 10 kilonewton, so I take it as 10 kilonewton. It is 12.73 upon d square into kilonewton per mm square. Just remember, for solving theories of failures we need to find out the principal stresses, the maximum principal stress and the minimum principal stress. To get the maximum principal stress and minimum principal stress, we need to find out the stresses, that direct stress or the axial stress or compression stress or and the shear stress. This shear stress, uh, tensile stress or compression stress, we need to find out. So to find out the stress, we know the formula, that is load per unit area. So based on that only we find out this term. Okay, this is stress is equal to load per unit area. Area we already calculate here and we put it here. Now the transverse shear stress is what, shear force upon shear area, the area of a bolt. Okay, so shear force is was 5 kilonewton, and this, so it will become 6.6336, sorry, 6.365 upon d square into kilonewton per mm square. Now we will put these values in the principal stress theory. So to get the maximum principal stress, we need to find, we have this formula which we have already learned in the strength of material subject. So sigma T1, that is the maximum principal stress, is what, sigma 1 plus sigma 2 divided by 2 plus 1 by 2 root of sigma 1 minus sigma 2 square plus 4 times t square. Sigma 2 is not known to us, therefore it is considered as 0. So we will get this value here in this term, sigma 1 by 2 plus half. Now let's put the value of sigma 1 and tau here. So we have already put it here. Okay. Now after solving this term, this 2, it will become 6.365, and here we get a common term, that is 6.365. So put it to the one side. Okay, we get it here common. So 1 by 2 is here, and we get this term by solving this term. This is 4 into. So this one and this one, these are square, that's why it is came out of the square roots. Now by solving this, what we get, that is 15.365 kilonewton per mm square. So this value which we get here, now we convert it in Newton. Okay, which is the preferable one. Now according to that is maximum principle, the first theory, it is the maximum principle stress theory, sorry, maximum principal stress theory. The formula is what, sigma t1 is equal to sigma tel, that means the elastic limit upon factor of safety. Factor of safety is not given, that's why we consider it as a 1. So according to principal stress theory, the maximum principal stress is equal to the yield stress. Okay, the elastic limit. So we put that value here. The elastic limit is what, 100 megapascal. So we get a value of D here by solving this term, that is 12.4 mm. You can use a calculator to get the values. Okay, you can check it. Now the same for the shear stress theory. To find out the shear stress theory, we know that the formula is what? According to the SOM, tau max is equal to this part, sigma 1 minus sigma 2 square plus 4 tau square. We put the value of sigma 1 and tau as sigma 2 is 0. Same calculation, same thing. So 9000 upon d square Newton per mm square we get here. Now I go to the maximum shear stress theory. It is what? That the maximum shear stress is what? Sigma TL by 2. So we get here 50 here. So now by solving this we get the diameter. Just see that the change in the diameter value. Okay. Now same thing for the principal strain theory. We have the value for maximum shear stress. Sorry, maximum principal stress. Now minimum principal stress is what? Only we have to put it a minus sign here. We put that value here, we calculate it, and after calculating we will get a value that is minus 2.635 upon d square. This is the negative value which we are getting. It is the minimum value. Now put this value in the formula. Okay, we have the formula here. Sigma T1 by E minus sigma T2 by ME equal to sigma TEL by E. So you will get this sigma T1 minus sigma T2. This is the one formula. Don't use this one. This is the good one. So put the values and just solve it mathematically. If you solve, you will get a value of 12.7 mm. Same thing for strain theory. We now have the maximum principal stress and minimum principal stress. Put that value only, just solve it. By solving, you will get the value of D as 12.78. Okay, we have put the values here and we solved it in very simple way. Okay, solve this bracket, and then solve this term. D raised to 4 is common for all, so we can add all these things. By adding all these things, we get these terms and you get the answer. Now, one theory is the distortion energy theory. Put these values here. We put it and we solve. What we get? 13.4 mm. So just think here that we are getting a value from 12.7 to 13.4 mm. So the value which we get according to the distortion energy theory is 13.4. That means each and every theory is covered here as the diameter is increased. That means failure will be less in distortion energy theory component. Okay, I hope you get all these things clear. So just remember, in by solving the for solving the numericals according to the theories of failure, that the values of two theories of failure should be close to each other. If we are not getting the closest value, that means you are going in a wrong direction. The calculation work is wrong. So just do the calculation properly and do it. If you have any problem related to this, just call.